Hello and welcome to my lesson on objects affecting each other. This is topic 9 if you're doing triple science, or topic 8 if you are doing combined science. It mainly covers ideas about forces that we have already looked at in topic 2. We will be recapping the difference between Newton's first law and Newton's third law, and looking at vectors and scalars very briefly, just recapping that. It is in paper 1, but it also appears in paper 2, so it needs to be revised for both paper 1 and paper 2. We're going to be having a look at the difference between non-contact and contact forces. We're also going to be having a look at some of the non-contact forces as well, which some of the ideas might be a recap and some of the ideas are new ideas. So firstly, I'd like you to have a think about if you can remember the difference between Newton's first law and Newton's third law. That's quite important. So difference between balance forces acting on an object and action-reaction pairs of forces. So have a think about that. And also, can you actually name any of the non-contact forces that we've previously listed? So when we were learning about Newton's first law, we talked about balance forces acting on a single object. So looking at maybe opposing forces, and if they were both the same size and going the opposite direction, acting on the object, then those forces will be balanced. With Newton's third law, we talked about action-reaction pairs of forces, where we are looking at two objects interacting with each other. So how are those objects actually affecting each other, rather than with the balance forces looking at forces acting on a single object. So that's a recap of something that we did in topic 2 right at the beginning. Names of non-contact forces, you might have thought of gravity or weight as we like to describe it, magnetism, and static electricity or electrostatic force as we sometimes refer to it. Okay, so what I'd like you to do now is have a look at all of these force names here and see if you can split them into those that are contact forces and those that are non-contact forces. So pause the video, have a think, maybe jot them down, and then you can unpause the video and check your answers. Okay, so here are the correct answers. As you can see, there are only 3 non-contact forces that we need to talk about at the moment, and the rest of them are contact forces. So can you, using that information, write a definition or write down the difference between contact forces and non-contact forces? Okay, so simply enough, contact forces are exerted when objects are touching each other, and non-contact forces, the objects don't need to be touching for them to be able to exert a force on another object. Okay, so what I'd like you to do next is to have a think about yourself sitting on a stool or sitting on a chair, and I want you to have a think about how we can compare the balance forces acting on you when you're sat down compared with the action-reaction pairs of forces between you and the stool or you and the chair. So pause the video and have a little think, see if you can remember the difference. Okay, so for the balanced forces, you've got, first of all, your weight caused by gravity is acting downwards on you, and the normal contact force from the stool is acting upwards on you. So here we've got both forces acting on the same object. And if the forces are balanced, then the person or you will stay still, you'll stay stationary or remain at a constant velocity. So you won't be flying up into the air or moving down towards the ground, you'll be remaining stationary. If we compare that with the action-reaction pairs of forces, you have got to think about the action-reaction pair forces acting on 2 different objects. So first of all, you are pulling the stool up towards you with your weight, which is caused by gravity. So you're exerting an upward force on the stool, and the stool is exerting a downward force on you. So here we've got the forces acting on 2 different objects. One, we're talking about the force exerted on the stool, and the other we're talking about the force exerted on you. So there's a subtle difference between them. Just to mention that both of these forces are similar, that we've got the weight caused by gravity of the masses. Here's another very similar example, but this time we've got a gymnast who is balancing on a beam. So have a think about the balance forces that are acting on the gymnast first of all, and then can you tell me what the action-reaction pair of forces is? Okay, so for the balance forces, we've got the weight of the gymnast is acting down on her, so very similar to the previous example, and the normal contact from the beam is acting upwards on her. So for the balance forces, both of the forces that we're talking about are acting on the same object, which is the gymnast. And for the action-reaction pair, we've got the gymnast is exerting an upward force on the beam, and the beam is exerting a downward force on the gymnast. So here we're talking about the force on the gymnast and the force on the beam. So forces are acting on different objects. So very, very similar to the previous example. Magnets and magnetism. We will look at magnets and magnetism in a later topic. We'll look at them in lots more detail, but just in terms of thinking about the force that they can exert on other objects, how is magnetism different to gravity? So if we compare magnetism to gravity, the magnetic field that occurs around a magnet can only exert a force on certain materials. So if something is magnetic or if something is a magnet, then a magnet will have an effect on it. But if it's not a magnet and it's not magnetic material, then magnetism will not actually affect it and the magnetic field will not be able to exert a force on it. In terms of comparing it with gravity, gravity affects all objects and all objects with a mass have gravity. So that's a big difference between magnetism and gravity. And the other difference is that in terms of comparing the two, gravity can only attract, whereas magnets can attract and repel. So you might remember from doing some work at Key Stage 3 that if you put two like poles, so for example a north and a north pole together, then they will repel, whereas if you put the north and the south pole together, they will attract. So magnets can both attract and repel, whereas gravity can only attract. But lots more to come on magnetism in a future topic. If you have a think back to Year 9 physics, you might remember doing some work on force fields right at the start of the year. These questions here can all be answered using knowledge that we learnt in topic 2 and topic 1 really at the end of Year 9 and the beginning of Year 10. So have a look at these questions and see if you can come up with some answers. Okay, so for this question here, what do we actually call the force field around the Earth that affects the Moon and also actually around the Moon? We call it a gravitational field. This question here about the Moon orbiting the Earth can be answered thinking about, first of all, Newton's third law, but also Newton's second law as well. You need to link those two ideas really to be able to answer this question. So here it's asking about the forces between the Earth and the Moon. Well, we can say that they are actually the same size and they act in opposite directions. I quite often catch out students and classes on numerous occasions with this question about which one, the Earth or the Moon, exerts the larger force. And it's a bit of a trick question really, because the forces are both the same size. The reason why the Moon orbits the Earth is because even though the forces are the same, the Moon has a much smaller mass, so it accelerates more than the Earth, and that's why we get the Moon orbiting the Earth and not the other way round. The Moon's gravity will affect the Earth, but you won't be able to see that as much. It's not as noticeable because the Earth has a much larger mass. And for this last question, how do we know that forces are vector quantities? Well, they've got two things. They've got a size or a magnitude and a direction. We represent them with arrows. So the arrow head shows the direction and the length of the arrow shows the size. So we can say that it's a vector quantity. This compares to scalar quantities which only have a size or only have a magnitude. So for example, mass is just a size or a magnitude, whereas weight has a direction and a size, so we would call it a vector. So the last force we're going to talk about in this lesson is electrostatic force. You may have talked a little bit about this in Year 9 when you looked at force fields. if you are doing triple science, we do a whole topic on static electricity and force fields. So if you're doing triple science, you need to know about this in a lot more detail, which will come in a later lesson. But just have a think, have a look at these pictures and see if you can come up with the answers to these questions. Okay, so you can see in the picture that these bits of polystyrene packaging are stuck to this person's arm here. And what we can say about that is that they must have opposite charges, because opposite charges attract. So it's a little bit like north and south pole. Opposite poles attract and opposite charges also attract. So one of them must be positive and one of them must be negative for them to be able to attract. I've just put in here as well that the arm will have an induced charge, and if you are doing triple science, we'll learn much more about induced charge versus overall charge when we get to topic 11 on static electricity and force fields. The size of the charges will actually be the same. So if the size of the charges are the same, then the size of the force is going to be the same. So linking this idea to Newton's third law of the forces being the same size because the charges are the same size. If both objects have the same charge, well, it's the same as magnetism. If the charges are the same, like when the poles are the same, the objects will repel. So, for example, if an object has a negative charge and another object has a negative charge, those objects will move away from each other and repel each other. So if we were going to draw a diagram of objects that are attracting and repelling each other due to electrostatic force, then they might look a little bit like this. So we've got these two objects. Both are exerting the same force on each other, and they are attracting because one of them is positive and one of them is negative. So opposite charges attract, and they're going to exert the same size force on each other, and they're going to be in opposite directions, but they're going to go towards each other. And if an object is repelling another object, say if they were the same charge, they would repel, the forces are still the same size and they are still going in opposite directions, but they are pushing away from each other. So that's the difference between objects that are attracting each other and objects that are repelling each other. Okay, so to finish off the lesson, I want you to have a look at this photograph of a boat floating on the sea. And I want you to think about what you've learnt during the lesson and jot down as many things as you can think of that you could say about what's happening, the forces acting in this photograph. Okay, so some of the things that you might have come up with in terms of Newton's third law, we've got the boat is exerting a force on the water and the water is exerting a force on the boat, and those forces will be the same size and they will be in opposite directions. So you've got the upthrust from the water and the weight of the boat. You could have said that forces are vector quantities, which would be definitely something you need to remember for both paper 1 and paper 2, and that is because forces have a size and a direction. You might also have talked about it in terms of Newton's first law, so we've got the weight of the boat acting downwards on the boat and the upthrust of the water acting upwards on the boat. So for Newton's first law, thinking about one object rather than Newton's third law, thinking about how these two objects are affecting each other. Okay, so that concludes the lesson. Thank you very much for watching and hope you have a great day. Goodbye.